Good day everyone. Hi, I am Dr. Hazrina Mansor. Previously, in lecture video, part 1, we have learnt general introduction regarding tall building. By now, we already know how to define tall building, why do we need tall building, how to categorize the tall building, and identify the tall building based on its usage. So, next, we're going to learn on the part 2 of the first topic, that is structural form of tall buildings. Figure shows the design criteria that must be considered in designing tall building. Meanwhile, here are the typical notes that must be considered in designing tall building. Alright, students, how to select the suitable structural form in designing tall building? Any idea? For your information, selection of the structural form involves selection and arrangement of major structural elements to resist loads effectively. This include a circumflex internal planning, material and method of construction. For example, as you can see in figure 4.1, the weight of the floor framing is influenced mainly by the floor span and is virtually independent of the building height. Meanwhile, the weight of the columns, considering gravity load only, is approximately proportional to the height. As we can see, 10 stories building can usually accommodate wind loading without any increase in weight of steel or member sizes. On the other hand, for buildings which are more than 10 stories, the additional resistance increases non-linearly with height. That's mean, for buildings of 50 stories and more, the selection of an appropriate structural form may be critical for the economy, and indeed, the viability of the building. Another thing that you must consider is the function of the building. For instance, an office building requires open space column-free area, like partitions. Services in ceiling caused story height greater than 3.5 meters. On the other hand, a residential building requires continuous vertical columns and walls repetitive corridor, in which a story height greater than 2.7 meters by identifying the building's function and material used. Therefore, it will provide architect and engineers a comprehensive view on the planning and design aspects. In general, there are 11 different structural forms that can be proposed in designing tall buildings. Bear in mind, at times, if the new concept of tall building design being proposed by architect, thus, there will be another possibilities of structural form that will be introduced. At this moment, the listed here are the common structural form of tall buildings that currently being used. As you can see here, we can either propose braced frame structure, rigid frame structure, infilled frame structure, shear wall structure, wall frame structure, frame tube structure, outrigger braced structure, suspended structure, core structure, space structure, and hybrid structure. Braced frame structure. Braced frame structure is the basic structural form for tall building. In braced frames, the lateral resistance of the structure is provided by diagonal members that together with the girders form the web of the vertical truss, with the columns acting as the chords. The most common type of bracings are single diagonal bracing, double diagonal, chevron, story height knee. This system is commonly used in steel construction. It is both an efficient and economical way for improving the lateral stiffness and resistance of rigid frame system. The bracing will almost eliminate the bending of columns and beams. Lateral loads primarily through axial stress, thus allowing for slender elements. A very well-known example of braced frame structural system can be seen in the Empire State Building. If bracing is used in concrete structure, thus, double diagonal bracing is requires. However, the use of bracing in concrete structure is unfavorable. As you can see in this figure, the construction of cross bracing is quite tricky in concrete rather than in steel structure. Such condition will trigger difficulty in segregating the concrete mixture equally, hence will have high tendency to cause honeycomb. Large-scale braced frame is another way of providing bracing in braced frame structure. This can be seen in Figure 4.5. However, the presence of either small or large-scaled bracings may obstruct view. Thus, as a solution, the braced bench shall incorporate a long wall and partition, lifts, stairs or service shafts. And suggested also, for bracing to overcross several floor heights, instead of one. Will you prefer this kind of view inside your workspace? In analyzing the braced frame structure, two methods of analysis will be used, namely member force analysis and drift analysis. Detail of the analysis will be explained in the next chapter, which is Chapter 2. The next type of structural form that you can propose in designing tall building structure is a rigid frame structure. In rigid frame structure, the behavior of rigid frame is governed by columns and girders joined by moment-resisting connections. The advantage of rigid frame structure is this type of structure provide open rectangular arrangement, thus easy to fit window and doors. This type of structure is economical to about 25 stories only. Above 25 stories, the design will become uneconomical, as it will end up with large member sizes, which hence difficult to control drift. Rigid frame is suitable for reinforced concrete due to the rigidity of the reinforced concrete joint connections. In steel construction, the moment-resistant connection is costly. The design usually required different floor framing design, causing lowest stories have deeper girders. For this type of structural form, you will need to use approximate determination of member forces, due to gravity load day circumflex euro 2 cycle moment distribution, column forces. Approximate determination of member forces, due to lateral load day circumflex euro portal method, cantilever method. Approximate method for drift, a circumflex euro components of drift, correction of excessive drift, effective shear rigidity. The method will also be explained in Chapter 2. The next form of structural is infilled frame structure. Infilled frame structure is common in many countries. Usually, it is suitable for a building up to 30 stories high. Commonly, the structure is framing either from RC or steel beam and column, later infilled with brickworks, blockwork or precast panels. In which, as you can see in the figure, the infilled play a role in resisting forces and stresses in the infill and frame. In infilled frame structure, lateral load is resisted by the infill, behaves as strut along its compression diagonal to brace the frame. However, it is also depending on the quality of masonry brick used. This figure shows an example of infilled structure with RC beam column framing, infilled with brickworks. Meanwhile, this figure shows an example of infilled structure with steel beam column framing, infilled with blockworks. And this figure shows an example of infilled structure with steel beam column framing, infilled with precast panels. For this type of structural form, you will need to design of infilled structure, the frame and check the horizontal deflection of the overall frame. The method will also be being explained in Chapter 2. Alright, let's take a moment. Students, can you clearly differentiate in terms of the structural behavior between the rigid frame and the infilled form structures? You are suggested to allocate 20 minutes for this task.